So we need to find the resistance RAB as seen from terminal A and B. When we look at the circuit, we can see there are several delta connections, but we will try to convert this delta connection into Y first. So these two, 32 and 20, these two are in series, so that they together will be 52. And if we convert them, so this is one resistance here, this is another resistance there, one node here, one node here, and one node here, three delta nodes. So maybe I will redraw. So that's 33, that one is 40 ohms, 33 ohms, and we are not doing anything to that. 50 ohms there, that 10 ohms there, 50 ohms staying there, 10 ohms staying there, and then this 10 ohms also is staying there, and 30 ohms there. This is also, so these are the same. Now what's changing is the other three. Maybe I will use a different color. So those are the three nodes, this one, and this one. So there will be, when we convert into Y, one resistance will be connected to each of the nodes. There were two resistances connected to each of the nodes when in delta, but in Y only one will be connected. So this is one, this is another one, and this is the third one. So again, these are the three nodes. This is the Y, converted Y. So now we have to look at the value. So this node, what the resistance that is connected here will be 40 in when we are converting into Y, the Y value will be 40 times 60 divided by 1. So 40 plus 60 plus 32 plus 20. So that will be, because these two are in just series, so 52. So it's becoming 2400 divided by 152. That's almost 15.79 ohms. So that is the Y value here. Then the resistance that's connected here at this node, that will, the value of the Y resistance value will be 40 times 32 divided by, this is the denominator will be always the same. So in this case will be 40 times 32 divided by 152. 40 times 30, 40 times 52, sorry, these two are together. I could have probably replaced that with one resistance by adding, but we have to always remember that these two are coming in series, so just one. So that will be 52. 40 times 52 divided by 152, so that is 13.68. So I will just write that directly, 13.68 ohms there. 13.68 ohms. And then finally this, the resistance that is connected here in delta, in Y will be 60 times 20, because these are the two resistance, 60 times 20 divided by 152, and that value will be 60 times not 20, 60 times 52 divided by 120. Again the same mistake, 50 times 60 times 52 divided by 152, and that value is 20.53. so 20.53 ohms. So these are the three Y value. So now when we look at the circuit, we still have two deltas basically. So if I redraw the circuit, what will happen is we have 30, it is 33 ohms there, not 3 ohms, 33 ohms there, and then we have again one node here. So maybe I will use now another color. One node here, it's the same as before, I don't know. So one node here, one node here, and then if we think of that, so another node is here, because these two are in series, these are the three nodes. So what can be, this can be drawn like this, 10 ohms there, and then I can draw it like that, and then we have like that, and then we have 10, 20 and 30. So this one there, this one there, and this 30 there, and we have this one there. So this is 40 ohms, this is 30 ohms, this is 20.53, the converted value there, 10 ohms and 10 ohms there, and this is of course 10 ohms and 15.79, 10 ohms, 15.79. so I'm drawing it to look like more like a delta, so I'm just adding these two value together, so that's 63.68 ohms. Now it's looking like a very classic delta connection. So this is one node there, this is another node, and this is the third node. Now I need to convert. What I will do, I could have done for this side as well, because we can see a similar delta is there as well, but doing any one will be fine, so I'm just doing the upper one. You can do the other one as well, just to match the results. Or yeah, so if I convert it, what will happen is this 33 ohms there, and then we have this resistance will be, now there will be one resistance there, and then one resistance there. I'm just drawing like that, and then another resistance connected. So better labeling the circuit. So let's call labeling the nodes. So this is, sorry, this node is, let's call it X, this is Y, and this is Z. So here the converted, this is the converted Y, that will be X, Y, and this will be Z. And we can see that here 10 ohms was connected to Y and 20.53 ohms resistance was connected to Z, because the part of delta is just these three resistances which we need to convert into Y. But 20.53 was connected to Z, which is connected there, here as well, and similarly 10 ohms connected to Y, that's there. Now we need to see what is the value of the resistance in Y that is connected to node X. That will be 10 times 63 divided by sum of 10, 15.79 and 63.8. So basically that will be 10 times 63.68 divided by 10 plus 15.79 plus 63.68. This will be the value that is connected here, connected to that resistance. The value of that resistance connected to node X. And that becomes, I have done the calculation, but I hope you can double check as well, 7.12 ohms there, and so that's there. And the value, the resistance that is connected to node Y, that will be the value of the Y, this Y is node Y, and delta Y, this is Y's resistance will be 10 times 15.79 divided by this thing, this sum. So this is almost 89.47, sorry, 47, this sum value. So now it will be 10 times 15.79, 10 times 15.79 divided by 89.47. That will be the value of this resistance, and that one becomes 1.76, this one 1.76 ohms. And finally the resistance that is connected to Z in Y connection will be, the value will be 15.79 into 63.78, 15, so this is the connected, that's to node Z, 15.79 into 63.68 divided by 89.47, and that one becomes 11.23 almost. So this is the circuit now. So these are the calculations. I will probably erase this part because this is, so that's there. So now, and this is, the circuit is still not complete, there will be the 40 ohms resistance here. So what we can see now is these two are in series, 1.76 and 10 ohms, and these three are in series, and then they are in parallel together. So what that becomes is like this: 33 ohms, this is 7.12 ohms there, and then we have like that and like that, and then we have 40 ohms, basically like that. So this value will be 11.76 ohms, because just sum of this one and this one, these two series resistances, and this side, this resistance will be sum of 11.23 plus 20.53 plus 30, which is 61.76, I guess, 61.76 ohms. So sum of all these three resistors, because these are in series, 11.23, 20.53 and 30 ohms. So now it looks pretty straightforward, I guess. So that's 33 ohms and then 40 ohms there. Now the parallel combination of 11.76 and 61.76, that will be, of course, here 11.76 times 61.76 divided by sum of these two, 11.76 plus 61.76, so that becomes 9.87. so this is 33 ohms, 7.12, 33 ohms, and then this one now becomes 9.87 ohms, and finally this is 40 ohms. Is now pretty straightforward. Now here AB, it was always AB. I didn't level before, but that's what these these nodes are. So now it's just 4 series resistances. So when we add them, it becomes approximately 90 ohms, 89 point something. So that's the result. RAB is approximately 90 ohms. So basically this problem was an exercise of delta to Y conversion, and this could have been done. So I converted this Y, this delta into Y. We could have converted alternatively maybe this delta into Y, or maybe the bottom one. We could have done any of those. So I have chosen to do the middle one, so it would be the same. So basically, yeah, that's what it is. And then we ended up with another delta connection. So that's the good part of the doing this problem, because we have to do it twice, so it's a better more practice. So yeah,